friends, welcome back. In the previous video, we have seen what workability means and the various tests conducted at the site. In this video, we are going to see how workability is measured at the laboratories. The various laboratory tests include the compaction factor test, VB consistometer test, and the flow test. Flow test is usually done for calculating the workability of self-compacting concrete. The first test is a compacting factor test. Let us see with an example. Assume that you are trying to transfer rice from the rice bags to a container. You lift the bag and place it near the mouth of the container and allow rice to fall into the container. After filling about 3 by 4th of the container, you will try to compact rice by shaking the container. In the same situation, what if rice is fallen from a particular height? When we compare both the conditions, the external energy required in the first case is more than that of the second case. Do you know the reason behind this? It is because the grains falling from a greater height gets compacted internally due to the gravitational force and you shake the container externally. Likewise, when concrete is made to fall from a certain height, concrete gets compacted internally and a less amount of external force is applied to compact the remaining concrete. Thus, the compaction efficiency will be more. This test, which considers the factor, is called compacting factor test. Compacting factor test has been developed at the Road Research Laboratory, UK. The degree of compaction, called the compacting factor, is measured by the density ratio, that is, the ratio of the density actually achieved in the test to the density of same concrete that is fully compacted. It is useful for dry concrete mixes of very low workability and insensitive to slump test. The apparatus consists of two conical hoppers and one cylinder. The dimensions of the apparatus are shown in the figure. The test procedure involves the following steps. For instance, let us take M15 grade concrete. Prepare the mix by using 1 part of cement, 2 parts of fine aggregates and 4 parts of coarse aggregates. Water content is calculated based on the water-cement ratio. It generally varies from 0.4 to 0.6. Now mix the fresh concrete. The inner surface of the hoopers and the cylinder is made free from moisture and greased. Close the trap doors of the hoppers. Measure the empty weight of the cylinder as W1. Fill the fresh concrete on the top hopper using a trowel without compacting. Then open the trap door of the top hopper and concrete flows to the lower hopper. Gently tapping is done by using a tamping rod to push the remaining concrete from top hopper to the bottom hopper. When all the concrete has fallen into the bottom hopper, remove the bottom hopper's trap door and let concrete fall into the cylinder. When the bottom cylinder is filled with concrete, remove the excess concrete from top of the cylinder and clean its sides. Now measure the weight of the cylinder with partially compacted concrete, that is W2. Then the cylinder is emptied and concrete sample is filled again in 3 layers. Each layer is compacted by giving 25 blows using the tamping rod. Now the concrete inside the cylinder is fully compacted. Weight of the cylinder with fully compacted concrete is measured as W3. Compaction factor can be determined by using the formula compaction factor is equal to ratio of the weight of the partially compacted concrete to that of the fully compacted concrete. The value of compaction factor varies from 0.7 to 0.95 based on the workability of concrete. Major advantage of compaction factor test is that it is used to calculate the workability of concrete with low water-cement ratio. The limitations of this test is that it is suitable only in the laboratory and the apparatus and maintenance cost is comparatively high. The next test is the VB consistometer test. This is a suitable laboratory test to measure the mobility and compatibility of concrete. This test consists of a vibrating table resting upon elastic supports, a metal pot, a sheet metal cone open at both the ends, and a standard iron rod connected with a glass disc. The time required for the shape of concrete to change from the slump cone shape to the cylindrical shape in seconds is known as VB seconds. This method is very suitable for very dry concrete whose slump value cannot be measured by slump test. This picture shows the dimensions of apparatus used. Now let us start with the procedure of the test. Place the slump cone inside the cylinder. Now fill the concrete in 4 layers with each layer as 1/4 of the cone height and tamper the surface 25 times. Once filled, stuck off the excess concrete. Move the glass disc attached to the swivel arm and place it on the slump cone such that it touches the concrete level. Note down the reading in the graduated rod. Now remove the cylindrical cone by raising the cone slowly in the vertical direction. Again, place the glass disc and determine the reading. Now switch on the electrical vibrators at the same time switch on the stopwatch. The concrete will start to spread in the cylindrical container. Continue the vibrations until the concrete is remolded and the surface of concrete becomes flat. Stop the vibrations and the stopwatch. The time in the stopwatch denotes the workability of concrete. The time is expressed in VB seconds. Calculations include by finding the slump value as the difference between the initial reading before remolding and the final reading after remolding. The workability conditions with respect to the VB time is shown in the table. Flow test is a laboratory test which gives an indication of quality of concrete with respect to consistency, cohesiveness, and the proneness to segregation. The figure shows the details of the apparatus used. The tabletop is cleaned and is wetted. The mold is kept on the center of the table, firmly held, and concrete is filled in two layers. Each layer is rodded 25 times with a tamping rod. After the top layer is rodded evenly, the excess of concrete which has overflowed the mold is removed. Now, the mold is lifted vertically upward and the concrete stands on its own without any support. The table is then raised and dropped 12.5 mm 15 times in about 15 seconds. The diameter of the spread concrete is measured in about 6 directions to the nearest 5 mm and the average spread is noted. The flow of concrete is the percentage increase in the average diameter of the spread concrete over the base diameter of the mold. Flow percent can be found by the following formula. The value of flow percent ranges from 0 to 150%. In the place of this test, a simple flow table test is conducted in sites for finding the workability of self-compacting concrete. This test procedure involves by filling a slump cone with concrete in two equal layers, each layer tamped 10 times with a tamping rod. Then the concrete is slowly raised vertically by the handles. After this, the tabletop is raised by handles to fall 15 times in 15 seconds. Then the concrete spreads itself out. The diameter are measured in two directions parallel to the table edges. The arithmetic mean of two diameters gives the measurement of flow in millimeters. Stay tuned. Thank you.